10 to 15 degrees of difference between day and night, almost in the month of June, like it happens today. And we can take advantage of this, because if we put this fresh air into the building automatically, we can cool the mass of concrete without cost. And then when this pre-cooling stops to be effective, we use geothermal exchange, but after the free cooling device that we can manage through the mechanization of the windows. Those are those devices. We can see the unit of air treatment that's on top of the building. Those are the systems that capture light on the rooftop to inject it in the different floors of the building. And this is the installation of the hydraulic mechanical parking that's under the floor. This is the parking at work. When it disappears, when it has to be used, every user asks for his car, it goes out, he takes it out of the machine goes down, he maneuvers and leaves the area. And the cars are there, they don't have lighting, artificial lighting, they don't have artificial ventilation, and they are extinguished. So the impact per car in terms of energy and CO2 production per year is 15% of the impact a regular parking has. And let's talk 5 minutes about geothermal exchange. Finally, I have explained to you, we use this parking facility to be again the structure, to be again a geothermal exchanger. We have supplemented it, in this case, with 6 vertical and 100 meters depth borehole exchangers. And we have a thermal pump, a geothermal pump. You're going to see them, they are up behind this wall, very quiet and small. And we have all this system integrated, we integrated into the building all this hydraulic system to transfer energy to the mass of the concrete to be our cooling and heating system. The ground behaves as a battery. The ground is heated or cooled depending on the amount of energy that we put in the ground. In summer, we have a temperature of ground, and in winter, we take it out and it goes automatically down. I know that in your countries, in Sweden and Norway, the point is not cooling, but heating, and these kind of systems have to be recharged many times with heat coming from the sun or other sources to be fully charged for the use in winter. But here we have a seasonal balance almost, and we have in this building we have 12 degrees in the coolest moment for the ground, and we have 26 degrees for the hottest moment for the ground. After all the winter, all the summer, we have taken heat from the building and put it in the ground, and the ground at the end of the summer in September is at 26 degrees. In winter, after winter, in February, we have been all the winter taking the heat out of the ground and giving it to the building. The ground gets to 12 degrees. Between 12 and 26, only 14 degrees difference. Those are temperatures of the ground that are very close to the temperatures that we have to have in water to give heat and cool to the building. That we are working for cooling with 18 degrees water, and for heating we are working with 36 degrees water. And very close to these temperatures of the ground. That means a big efficiency in the transformation in the transfer of heating and cooling, for heating and cooling of energy from the ground to the building. This is the diagram. And once again, you see that in Madrid we need more cooling than heating. How is it solved in this building? Well, this building has an underground source of water, and water runs through the underground. And water in Madrid, in a non-disturbed depth of the ground, non-disturbed in terms of energy, is at 15 to 16 degrees. So we have a permanent source of water that runs through the ground at 15 to 16 degrees, and we can use this water to dissipate heat in summer and to improve the cooling behavior of the building. So once again, we are combining geothermal exchange and storage with a renewable resource that in this case is water running through the ground. And well, this is the construction. In this courtyard you have here all these devices. Once the building the structure was preserved, and we were beginning the works, and we drilled, we prolongated the structure with these piles that were provided with polyethylene circuits for the circulation of water, and the installation of the parking was made within this structure that was already thermo-activated, and all these water circuits go to the pump, geothermal pump room that's under that wall, under the ramp of the garage. Formerly, the machine room of this building formerly occupied what now is the personal area, 2 floors and almost 100 meters surface. Now everything is right there. And then in the building, the slabs are provided with pipes, as I explained, and all of this is very well programmed and coordinated with the energy and the information that's also provided in several points of the slabs, and all this is integrated. Every floor has its collector drawer to control the conditions of every circuit, and then we provided this slab with 7 centimeters more of concrete, because it was a very regular slab with only 5 centimeters of concrete, and we needed at least 12 to have more or less the 300 kilogram per square meter mass that we have here for cooling and heating, active mass. And through this process, when we make a rehabilitation of an old building, we can thermo-activate its slabs, and then we get to the result that you are going to see, and that's again fully integration. Full integration in this building, eliminating all these fan coils allowed windows to come to the ground, improving lighting, improving the interaction of sun with the floor, as the floor is provided with piping. When sun hits the floor, it can hit the water, and you can redistribute the piping, the heat into the building, so you have interaction between different systems, and then we can eliminate all the nets of distribution of air and integrate all the system in the building. This is the area that's recovered as personal area after eliminating the installations that occupy this area. All of this fully integrated with a custom-made by us program using free software, using free hardware, and making a programming that has been directed by efficiency strategies and has implemented elements of information, elements of control, elements of actuation on the building at several steps, distributed and centralized and accessible to different kinds of users. And this building, mostly, what we can say is that gives the users and gives the maintenance personnel tools for knowledge, tools for acting, for strategy, and for interaction with the building. It's a building that's fully governable, and that can be drawn to efficiency because it gives information, accurate information that we have designed to be received, and it can act controlling days, weeks, months, and also future provisions. The result, and this is the last slide, is that we have reduced the consumption energy of the building, at least, because it was an estimation on the old building, at least by 86%. We have gone from these 210 kilowatts hour per square meter that are very normal in Madrid to 30 that have been monitored for the last 4 years for climate and lighting. The reduction of maintenance, because all these systems work with a very low pressure, with very low temperature and very low speed. The reduction of maintenance has been almost 63%. The rehabilitation has recovered 15% of the surface of the building, almost 120 meters that were completely misused and occupied by former climate installations. And we have provided 14 parking spaces. The building, in terms of utility, is fully functional and operational with excellent health, ergonomics and environmental quality. And as a real estate asset it has almost doubled its value, including all the costs that are involved in this operation from the moment the building was bought. Finally, this is what we are talking about when we talk about efficiency and efficiency intervention. Is multi-dimensional. It includes and integrates all the facts, and it considers that all the facts are opportunities and for results. So we can take a tour on the building, and you can ask as many questions as well. If you have some questions now, it will be a pleasure. Now we take a tour. Yes, please.
Do you carry out surveys to find out how people experience the buildings, whether they work or live in the building?
If we have feedback from them,
yeah.
Yes, we have. In fact, not only feedback, but one thing that we do, and we are very fond of doing more and more, is that instructing users and instructing maintenance personnel. We also remain in contact during lifetime of the building, in touch, because we collect information all the time. In fact, we are linked through TeamViewer with the managing systems of all the buildings we do. We can connect with them through our computers, and people interact. And in this building, users also interact. All the systems are not only automatic, they can be configured as automatic systems, but also they have a position where users can interact. And not all the systems are thought to be interacting with users. In this building, natural light systems are thought to be interacting with users. Why? We have a building just in front that makes very complex and complicated the natural lighting conditions that come. So people is never satisfied. And they have the option of auto-regulating themselves the position of the louvers of the facade to achieve a comfort situation. And in terms of time, in 1 year, they had begun to do this operation, and in terms of 1 year, they have arrived to a standard solution. They checked twice a day, and they regulated slightly the position of the louvers, and our building is collecting the information of what they are doing. And we have continuous feedback with users. This is an example. In this case, it's natural light because it's complex, but we have continuous feedback with users to see what their behavior is, because finally, comfort and efficiency is a fact of balance between technology and user perception. No? And for us, this is very important. We not only collect information for having feedback on the results, but we involve users and personnel in the efficiency of the building as agents.
Okay, that actually leads to another question, because I think I've learned that the hardest thing about energy renovation is to have the calculated values actually meet the practical measurements, as in you don't get the savings as you expected because the users don't behave the way they're supposed to.
Well, it can be like this, but this is also you have to manage this. Human factors belong to our project, are in our project. You cannot suppose that you deliver the building and that it has to be used in a certain way if you have not included in your project the way of operating, management and interaction with users. And this is what we do. In fact, what is energy savings? Energy savings, in fact, is the difference of a calculation of energy expenditure and the real measurement of energy consumption. No? And all these facts should be implemented in the estimation. In fact, what you do is modeling and simulating the behavior of the building in the future, and then you have to consider that your action to reduce this consumption, that's also modeled and simulated, involves certain elements, including users and operating model behavior. No? And you cannot forget, you can never forget users. No? In fact, there's a limit for this, that there's a certain level of instruction and of behavior that users have to have. Those are some limits that the system have, and you have, of course, to negotiate at the beginning of the project with the client. You cannot negotiate the limits of the users after the project has.
So how do you educate the users? Do you give them a course or do you give them a manual?
Yes, no, depending on the building, some systems are critical in terms of perception. In this building, we don't negotiate with them about climate or cooling and heating, but of course lighting is a major concern for their work, and lighting, they are involved in lighting, so they have been instructed in lighting to interact with the building, no? And they are doing it, and we are collecting their experience, and their experience will be implemented in the automatic systems of the building.
Okay, so in relation to Scandinavia, the problem is that when people move into an energy efficient building, they think, oh, this is energy efficient, it's cheap to heat up, so they just turn up the heat more. So you don't really have the same savings as you.
No, I'm sure that it's like this, but this is again, as you are pointing, no, a fact of instruction. So if people are instructed, this is an energy efficient building because it achieves comfort level with efficiency. People has to be instructed to respect the importance of energy sparing, no? But of course, you have to put a limit of their capability to interact with the energy sparing systems. You have to have some limits in this capacity of interaction.
So you would tell them to put more clothes on instead of...
Well, you instruct people to interact with the building with responsibility, but then over and under the responsibility there are some technical limits to their possibility to manage. No? Both things have to be done. You have to give people the possibility to be responsible, but you have to put limits to these possibilities. Both things have to be done at the same time, and communication is a critical issue in efficiency. Regarding a car, you can have a car that's efficient, but you can drive it with any efficiency. So finally, efficiency is a fact of human-machine interaction. Absolutely. If not, they're not efficient buildings. If users and managers and operators are not efficient, there's no one efficient building.
So I guess you can say buildings are machines for living in?
Buildings are machines. Well, this is not mine. No, from my point of view, buildings are exactly interfaces between man and the mean. What the opportunities for comfort are there, what we need is there. And we have to be considered the center of our activity, not the building. We are not cooling or heating buildings, we are cooling or heating people, and we are doing it through buildings. So finally, building is a machine to transfer resources to people more than a machine to live in. Well, that belongs to the mechanism of the 20s of the last century. I understand very much why, and it was a fascinating time where machine was driving civilization, but you know the consequences. We are living them. The blind belief in progress, and progress as a positive direction. Progress can be the progress through a cliff. This blind faith in progress has drawn us to the situation we live. Machines have to be driven by people, and man-machine interaction is the point of efficiency today, not technology.